we started part B yesterday, and remember we talked about how like some of these you're going to have to do without a calculator. Dylan, look at the door for me. And we also talked about, right, the base. So f of x and the inverse, okay, have the same base. So when you are writing the inverse, those bases are going to be the same. Okay, so exponential and log functions are inverses. And then we did part of this together. So when you are finding what this is, if you have -2, -1, 0, 1, 1.5, we talked about if it's a decimal, okay, then you're going to, you could use your calculator for that part, but when you're doing this on a no calculator section, I would only have that, and I'd give you something like 2. Do you guys remember what happens if you have the negative here? Then the reciprocal is 1 over 4 would be 4, and you raise it to the positive power. So 4 squared would be 4. 4 to the first is 4. Sorry, 4 squared is 16. Anything to the 0 power is going to be 1. This would be 1/4 to the first power. Okay, and then like I said, for one like this, we don't know how to do that yet, so you could use your calc. I'll put a calculator for that. Okay? Then, for the inverse, all you have to do is what? How do you find the inverse? Yeah, you're just going to switch x and y. Okay, so when you switch your x and your y, you have 16 -2, 4 -1, 1 0, 1/4 1, 0.125, 1.5. Okay, and then when you're graphing, and you're graphing inverses, what's something that you definitely want to have on your graph? What's that? Yeah, what's that line of reflection? We are going to look at those. But remember, what's this line called? Yeah, this is your line of reflection, your y equals x. Because with inverses, what is special about this line? What should happen? Yes, they are reflections of each other over that line. Mm-hmm.
Is it going to always be in the same place?
Yes, because it's the same equation, right? So your intercept is always 0, 0, your slope is always 1, so y equals x, yes, it's always in the same place. Just like the y-axis is always in the same place, the x-axis is always in the same place. Okay, and then the domain and range, we also talked about that. So when you are doing the domain for exponential functions, okay, what is the domain for every exponential function? All real numbers. Okay, and then we'll go ahead and graph it, but you should know your range as well, because remember with exponential functions, they're always approaching what? 0, and that is the asymptote. So that means your range should be y is greater than 0. Okay, so then let's graph this. I have to go out to 16, so I'm probably going to want to do this by 2s, right? 2, 4, 6, 8, 10, 12, 14, 16. Okay, to get all my points in there. You guys concur? Okay, so 2, 4, 6, 8, 10, 12, 14, 16. Okay. All right, now we're ready to plot our points. So -2, no, -2, -4. Okay, so at -2, I'm at positive 16, which is right here. At -1, which will be halfway in between, I'm at 4. At 0, I'm at 1. And then look, these are getting so small because what is happening? Yeah, it's decaying. So this is going to get closer and closer to what? Yes. And then look, all you have to do is draw this going along the axis. Okay, that's your exponential function. How'd you do? Good? All right, let's do the other one. I'll use this. Okay, so first, when you're doing the domain and the range, your F inverse is your log. Okay? Now, just like the X and the Y switch, the domain and range switch. So if your range is Y is greater than 0, your domain is now what? X is greater than 0. And then if your domain was all real numbers, your range is all real numbers. Okay? And we also talked about this yesterday. Remember, if the X and Y's are always switching, and with an exponential function, it's getting closer and closer to the x-axis, what are we going to see with the inverse? What's that going to get closer and closer to? The y-axis. Okay, so let's look. So now I have 16, negative 2, which would be right here. Okay, 4, negative 1, right here. 1, 0. And then these are so small that, again, they're going to get closer and closer to the y-axis. So I'm going to connect this curve, and it's going right along here. So see how this is like an exponential function, but turned the other way? Doesn't that look like an exponential function? Yep, it's just going the other way. Okay? All right, and then again, use this line to help you. Is this a reflection? Yeah. Does this side mirror this side? Yeah. All right, what questions do you guys have for me about the graphs? We might do another graph together today without a calculator, just to make sure we got those mental math skills working, okay? All right, and then yesterday we started this one. So we talked about how the pH has a special formula. It's the negative log or opposite log of the hydrogen ion concentration. And that's the equation that you're going to use to find the pH of each of these substances. Okay, so let's do that right now. So we're going to do the negative log of 1, 2, 3, 4, 5, 6. So there are 6 zeros here. 2, 5. 1, 2, 3, 4. And then we're going to round that to the nearest tenth. All right, so what do we get for the first one? Yeah, great, 6.6. And again, just make sure, use the negative, not the minus. Because if you do, then you're going to get a syntax error. So we have the log button. Okay, and then 6.6. Awesome. Okay, what about for the tomatoes? Awesome. Okay, and then B says, what happens to the related pH as the hydrogen ion concentration increases? So if we look at the chart, it's increasing because it's getting closer and closer to what number?
1.
0, right? I mean, I guess technically maybe it is getting closer to that, but we can see that the numbers are getting larger, right? Because you have less zeros there. And then what's happening to the pH? It's going down. Okay, so we're just going to say the pH level decreases.